Now we are going to conduct an experiment, that is for some mechanical engineering metrology and measurements lab. The name of the experiment is calibration of LVDT. LVDT means linear variable differential transformer or transducer. It means linear variable differential transformer is a type of electrical transformer or a sensor used for measuring linear displacement. Linear displacement. In this experiment, we are going to take the displacement of the this calibration of the micrometer with respect to the LVDT. Next, in this, the major specification of LVDT is it going to be plus or minus 10 mm. Going to be distance is going to be measured plus or minus on the micrometer, plus or minus 10 mm is going to be measured, and the micrometer range is 0.25 mm. Least count of the micrometer is 0.01 mm and linearity is plus or minus 1%. Right? This the here the all the cables or wire is going to be connected with the color coding ports here as shown in the device. On the device, power is already on. This is the display, LVDT display. Next, it is a core is going to be here, going to be connected, and another one is the micrometer is going to be connected here. The one complete rotation of micrometer is going to be a half mm. A two rotation when it completes 1 mm is going to be takes place, because on the micrometer scale only the 50 mm 50 divisions are there, hence two rotations are going to complete for 1 mm rotation. First we are going to make the here 0 before calibrating. First we are going to mention this, show the knob, operating the knob. We have to first show or make it this display, digital display for a 0. Next we go for micrometer. The distance should be a 10 mm. Why? Because 10 mm means, the 10 mm means it is a null point. Null point means it is an exact center point. There the voltage is going to be 0. From this make at a center 10 mm, we are going to start rotating in a forward direction. Here the when you starts rotating this forward up to 0, the here display is going to be changes. See, I am rotating this micrometer, this display is going to be changes up to 0. Up to 0 we have to make, rotate the whole micrometer. Afterwards we have to go for a calibration. Here in the micrometer reading, it shows a 0. Next, here what it is showing in the micrometer reading, there is showing 0. Here it is going to be exact 10.14, but we are to travel a distance of 10 mm, but it's showing 10.17. 0.17 mm is an error. We have to make a correction. That correction is going to be made by making a calibrating. How it is going to be calibrated? Here in this, using the help of this calibration knob, we are going to make that it to be a 0. This knob is very sensitive. Slowly we have to operate. Exactly, this is 10 mm. It's very sensitive, and the fluctuation is going to take place. Small disturbance in the cable also it going to be changes. .9 or 10.10. Again we go for remain. I go for the 10 mm again go or for a null point. This and up to 10 mm for a beginning point or a null point. What you start taken an initial point. The this display or a digital display shows a zero value, and then only our instrument sheet calibrated. Here it is going to shows a 0 or zero point 0.1, the small disturbance in the now, hence it going to be our, we can say our instrument is calibrated. Then what we have to do means, now we are going to take a 2 mm intervals of 2 mm micrometer difference or movement, forward movement is going to take place. Then we are going to mention for readings 2 mm SD reading, displacement reading, or we can take as 2 mm here micrometer reading, 4 mm, 6 mm, 8 mm. For these values, what is the load cell or LVDT which this or this device is going to give us, the what type of value is going to give us, we are going to be writing, or we are going to take here. First we are going to take a 2 mm of movement. 1 mm is going to be completed. 2 mm it going to gives 2.01 or exactly 2 mm, 2 mm or 2.01, 2.01 mm. Next again for again another 2 mm. It means a 4.03 mm. Next again we move for a 2 mm. 6.05 or 6.05 mm. Next again go for a 2 mm. 8.05. Again another one consider, we are going to take another one reading, another 2 mm. 9.98. Nine point nine nine, 9.99 mm. Here a 10 mm. And then take the difference of this 2.02, it means 01, 4.0303, 6.0505 mm, 8.05 mm, here minus 0.1 mm. Hence again we are going to calculate the percentage error in terms of SD minus of SM divided by SD into 100, that gives the percentage error. Then again we are going to plot the graph indicated or displacement reading versus micrometer reading, that gives the calibration reading, and the graph shows the linearity or how much the difference is going to be takes place.